Hi guys, it's Mrs. Spiro. So today we're talking about angle relations. So I think the hardest part you did happened already. So naming those parts of angles and making sure you understand what distance means in midpoint. So I think that was the hardest part of that, or of this chapter. So here we're going to talk about special angles and knowing a lot of vocabulary term. I keep saying a lot of this is vocabulary terms. So get your highlighters out, which I don't have mine. Here it is. And a calculator out, which I don't have, and here's mine. Okay, so here we go. So adjacent angles. The big thing about adjacent angles is that they have a common vertex and a common side. So they share that. So here's an example of yes. So angle 1 and angle 2 share this common side and they share this vertex. So this is a yes. This is a no because actually they're both yeses because they share a common side, which is here. If I'm looking at it this direction, and they have this common vertex. So these are non-examples. So angle 3, so this one right here, and it's always good to mark it, and then A, B, C. So that, see how they don't have a common, you're saying, well, they have this in common, but this is on the interior, so they cannot have this interior. So this is a no because they have angle is inside another. Inside, that's a good one. That's okay. Angle inside another is a no-no. So this is a big no-no. Let's go back and say yes. Okay, this one, so angle 3, which is here, and ABC are completely different. You're saying that maybe they're sharing this, but they don't have a common vertex. So there's this vertex and here's this vertex. So they are not sharing vertex here. So I like this because it gives two good examples of what is not adjacent. Okay, this next section. A linear pair. Linear means line. Linear means line. Straight line. So these two form this straight line here. Actually, I'm going to do this. I see no straight lines. So no straight lines. That one was super easy. Okay, so here, vertical angles. Vertical angles is just an intersecting or intersecting lines. Two intersecting lines. So, and they're straight lines, vertical angles. Two, let's put straight. I need a special word that means straight, so you don't have to write all that. Okay, so angles 1 and 2 are considered vertical. So this goes with this, and then this one goes with this one. And we'll learn that these two are equal or congruent, and these two are congruent with each other. Oh, it says that right here. Vertical angles are congruent. So in these little lines that I just made, it's just like those hash marks. So this one has one, this one has one, therefore they're equal. This has two, this has two, so that means they're equal. Making pictures, drawing pictures, and labeling is going to be your friend in geometry. All right, so here we have this roadway. We need to name an angle pair that satisfies the condition, two angles that form a linear pair. So I'm just going to make a straight line. And what two angles make that straight line? I'm going to say UIP is the one I'm choosing, and PIR. So this one and this one. So angle, what did I say, UIP. Remember, the vertex is always in the center, and angle PIR. Okay, so that's that one. Roadways that name an angle pair that satisfy the condition as two acute vertical angles. So vertical. So let's see here. So two angles that cross, and I'll just go ahead and use this guy. So this guy crosses with this guy. Okay. So two angles that form a, satisfies it at two acute vertical angles. So which one of this that I created are acute? This one and this one. So PIU is an example, which is equal to its other opposite of the angle opposite. So RIS. And that's angle. So if I needed to name a pair, I just added this. So add that, please. Name a pair of adjacent angles. And adjacent angles, which means they share a side. So really, that would be no different than up here. The two angles that form a linear pair. So adjacent, because they're sharing this line right here, I'm going to use that same one. So UIP and PIR, they share this and they also share that vertex. So I'm going to use that same pair. Now, if you stop this and wanted to do this on your own, there's several different answers here. I just gave you an example. Next. Okay, so now we're back to that vertical angle. So these are called angle pair relationships. And one of those is that vertical angles. And I said earlier they are congruent. So I'm going to mark these a little bit better. So what they're saying is that this angle here is congruent to this angle here. This angle here is congruent with this angle here. And you're going to need to know this, so definitely understand that. Somehow make yourself memorize that. Complementary angles, I think you've done that in the past. They equal, the sum are equal to 90. So these two together, so all of these, so angle 1 plus angle 2 equals 90. Or they could be together, so they could be adjacent, or they can be separated. Either time you can say, oh, these two are also complementary. As long as they equal, so angle A plus angle B equals 90. Okay. Supplementary, that means their sum is 180. So, and usually you could find these. Obviously, you're looking for a 90-degree angle here, so you're looking for 90 degrees. Here you're looking for 180 degrees, and that is that straight line, that straight angle. That's 180. Back here, you're looking for that box that shows that you have a 90-degree angle. Okay, so you can see here, that's a straight line. So these two together form 180 degrees. So angle 3 plus angle 4 equals 180. These two together equals 180. So again, I could say angle P plus angle Q equals 180. And they're still considered supplementary. Okay. Find the measures of two supplementary angles. So I'm going to have to draw a picture. Supplementary angles, that means they form a straight line, and then one zips off like that. Okay, so if the measure of one angle is 6 less than 5 times the measure of the other. So we're going to say 6 less than means minus 6. 5 times this one, like that. And to solve that, you would just, these two together equals 180. So 5x minus 6 plus 1x equals 180. 6x minus 6 equals 180. Plus 6 plus 6. 6x is equal to 186. Divide by 6. Divide by 6. I know, I kind of go fast. 186 divided by 6 is 31. So x is equal to 31. But I'm not for sure. Is that my question? Find the measures of the two supplementary angles. So this one here is equal to 31. This one up here, I'm going to have to say 5 times 31 minus 6. 5 times 31 minus 6 is 149. So these would be my answers. Okay. Next, more vocabulary. It's my favorite word in math. This one in hypotenuse. So perpendicular lines. Perpendicular means 90-degree angle. That's all it means. And you can see that it forms this, it always has that mark in it. Here's the symbol. And sometimes they'll have it written like that. So you'll need to know how to read that. So A to D is perpendicular to C to B. Okay. All right, so here it says to find x and y so that KO, so K to O, sometimes I like to outline these, K to O and H to M are perpendicular. So that's why I put in these little boxes. So you can see that this side and this side are 90 degrees. So having said that, I know that this is going to equal 90. And these two together are going to equal 90. So let's solve. Let's start with the y. 3y plus 6 equals 90. Subtract 6. 3y is equal to 94 divided by 3 divided by 3. 94 divided by 3. Okay, I am going to leave y as an improper fraction for now. 3y plus 6 minus 6 equals 90. Why did I put 94? It should be 84. I was wondering why that didn't work out so well. Let me back up. Hope you guys caught me on that. That would make more sense. 84 divided by 3 gives me 28. So y equals 28. Okay. Over here, we have 3x plus 6 plus 9x equals 90. So that's 12x plus 6 equals 90. Minus 6 minus 6. 12x equals 84. Divide by 12, divide by 12. X equals 84 divided by 12 is 7. So there we go. Okay, so this is almost like the game of Clue. They're going to give you, in geometry, they're going to give you a bunch of clues like this. And you're going to have to use your knowledge of geometry to say, hey, that's a right angle, therefore this is going to equal 90. Hey, these two together are going to equal 90, so I set them together equals 90. So those are the clues they're going to give you, and you're going to have to get really good at that. All right. All points shown are coplanar, so that means they're all in the same plane. G, H, J are collinear, so it's forming that straight line. H to M, H to L, all of these intersect at H. Where's G to J? And they all actually could be all, most of those are rays, and that's part of a line. Okay? H is between these two. And they're showing, well, we'll get to that. L is in the interior, so here's L, of MHK. G, H, M, and MHL are adjacent because they share that common side. G, H, L, and L, H, J are a linear pair because together they make this straight line of 180 degrees. J, H, K, and K, H, G, these two are supplementary. So again, these are almost identical. Linear pair and supplementary would be the same thing. What you cannot assume is H to M and H to L is perpendicular. So you cannot say that. Otherwise, they would have that little 90-degree angle box. You cannot say that J, where's J? H, K, and G, H, M are the same. You can't say that this angle is the same as this one because you don't have anything, you don't have like vertical lines. You don't have those intersecting lines. These are not straight intersecting lines. And the same with these. You cannot say that GH is congruent with HJ. The reason why, because it doesn't say that H is your bisector. Okay, and so these are all going to be the same thing. Unless it says that they are, or if there's markings on that, you cannot assume anything. All right, let's move on. So, how do we do this? So we're going to say the measure of VYT equals 90. So here it is. Where's VYT? This right here, VYT. VYT is 90. Can we say that's true? Yes, we can. Because we can say that XYT, or we could say that these two angles are a linear pair. So let's do that. Let's say because angle VYT is a linear pair with, I always do with like that, VYX. Okay, questions on that one? And I guess linear pair and angle, let's keep going here. Angle VYX was equal to 90. Therefore, angle VYT would equal to 90. Okay? Supplementary, so that means equals 180. So TYW, where's TYW? So this one right here. And TYU are supplementary. Yes, because they form a straight line. So they are a linear pair. Yes, because they are a linear pair, and linear pairs equal 180. Okay, next one. Where am I? Oh, VYW. So VYW. So this one here. I'm going to erase all my junk here. It's getting a little confusing. So VYW, this is when your colored pencils or pencil that you can erase, VYW, and TYS. Are those adjacent? No. Why? There's no common side. No common shared side. I guess it means the same thing. Okay. All right, so if you want to take a break and work on the first assignment, you may. You can stop here and then come back to this later. That's fine, but I'm going to go ahead and keep going. So we're talking about two-dimensional figures. So how to name polygons, finding the perimeter, circumference, and area. So naming polygons, perimeter, circumference, and areas. Okay. So a polygon is unique because it's a closed-sided figure, and it can have all kinds of different shapes and number of sides. Closed mean it goes all the way closed, means it's not open. This would be an open, see how that's open here? That is not a polygon. That's called, this one's closed, this one open. So therefore this is a polygon and this is not. The vertex of each angle is a vertex of the polygon, obviously. So a polygon is named by the letters of its vertices, written in the order of consecutive vertices. So I don't care where you start, but this is G, and it just goes and names it like that. Okay. They've got the sides named, the side, they're like segments, and here's your vertices. Okay. Polygon are non-collinear, so it doesn't have a in a straight line. Each intersection, each side intersects exactly at two other sides by only at their endpoints. So this intersects with this at one endpoint. Convex. This is considered a convex. So this is a convex figure. If no line that contains a side of the polygon contains a point in the interior of the polygon. I don't know what that is. Concave. A concave polygon is a polygon that is not convex. Okay, and let me give you one that's concave. So this would be concave because you've got these on the interior. It's like a cave. I think of it as a cave. It caves in. Okay. This is like a balloon, but with not the rounded sides, but nothing caves in interior-wise. Equilateral. So all of the equilateral, all of its angles are congruent. Equal angular, I have those backwards. I knew I did. If all of its angles in the I'm going to stop here. Let's change this. Equilateral means all sides. All of its sides are equal. All of its equal angular is all the angulars in the interior are equal or congruent. So this would not be, this is an example of where, because all of these angles are different. Okay, so that's what that means. I apologize. Okay, to be a regular figure, that means all sides and all angles are congruent. Irregular means the opposite. Now, an example of a regular figure would be a square. A square is an example of a regular figure because all angles are equal. So all of these are 90. And then all of your sides are congruent. Okay. I have no idea what these are. Don't know, sorry. It's okay. Sometimes less is more. Okay, so hopefully you know your types of polygons, and you should know your prefixes. Tri meaning 3, quad meaning 4, penta meaning 5, hex is 6, and I always remember that because the number 6 has an X in it, and so does hex. Hepta is 7, or septa, sometimes like septuplex. Octa, 8, non is 9, deca, 10, just like a decade. Decagon is 12. Do meaning 2, 10, so that equals 12. And entagon is anything more than 12. And flip this page over. So if you have an entagon and you have more than 12 sides, you can just call it by the number, not a hashtag, of sides it has. So it could be like a 13-sided figure would be a 13-gon. Just FYI. All right, so here you have to pay attention to these markings. So we need to say, are these concave, convex, or is it regular or irregular? This is convex because it doesn't have anything on the interior. So convex. And it's irregular because all the sides are different. All the sides are different. Remember, they'd all have to be the same to be regular. And how many sides does this have? 1, 2, 3, 4. So you would call that a quadrilateral. I was going to say, I think it only has one L. I swear, in my old age, I'm losing my vocabulary. It's kind of sad. Okay, so this one is how many sides? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonagon. None of the sides are the same, so it's irregular. And it is concave because this goes inwards. Maybe that's what that word was on the other page. It goes inwards. All right. Next, finding perimeter, circumference, and area of our different shapes. So for a triangle, first of all, perimeter is rim, so the outside. Circumference is around. And area is inside. All right. So perimeter of a triangle, you just add your sides. So on this one, you would say side plus side plus side, or C plus B plus D. To find area, it's so many different ways to write this, but it's a half, and I always like 0.5, base times height. Base and height can always be found by that 90-degree angle, and if you look at this, this forms a great H. So has to be, to find your base and height, it always has to be perpendicular. Square. You could say side plus side plus side plus side, or 4 times your side. And then your area is base times height, or side squared, because it's the same thing, side times side. Rectangle, you can have length plus width plus length plus width, because that's L and W. Or you could say 2 times your length plus 2 times your width. It's almost like simplifying it. Area is length times width, or a lot of times we still say base times height. And again, your base and your height forms this 90 degrees. Circumference, there's two of those. Make sure you know your radius is only half. Your diameter is all the way across. I prefer you to memorize just one. So I'm only going to give you one, which is 2 pi r. Area is pi r squared. And to remember or know the difference is area's label is always squared. All right. Find the perimeter in area. So this is a rectangle, so we're going to say, I don't care how you do it. You could do the 4.6 plus 4.6 plus 2.3 plus 2.3, my perimeter. Area is, and label these length times width. So 4.6 times 2.3. I know it's my base and height because of this 90 degrees. So you can either add those up and multiply those to get your answer, but I'm going to go ahead and move on because I know you guys are getting tired. Hopefully on B you know this is your radius. So I'm going to mark that with an R. To find my circumference, so around, which is the perimeter of a circle, I am going to say 2 pi r. And then I could simplify this by just saying 8 pi. And sometimes we want to keep it like that. And sometimes we want it to solve that. So sometimes they'll ask you what is, they'll say keep it with just this, use this, and then you would round it to the nearest hundredth or whatever they ask for. Or they would tell you to use 3.14. So that one can get a little tricky. You really have to pay attention to directions. And then, so that was my circumference, which was the perimeter. And then my area was equal to pi r squared. So you could say that is 16 pi. I'll just leave it like that. Okay. Are we done? Yay, we are done. All right, so you're going to have 2 assignments with these 2 lessons here. And again, if you have any questions, always reach out.